Hello everybody. So today we are going to talk about another kind of organic compound called alkenes. Alkenes have carbon and hydrogen in them and they are organic. So let's look there and see what we can learn about alkenes. So alkenes are another kind of hydrocarbon. They only have C and H in them. They will use these same prefixes, but what's different about them is that they are unsaturated, meaning that they have at least a double or triple bond. Alkenes have the double bond, so they are unsaturated. So they are going to use a different formula for their hydrogen number. Remember, alkane was times 2 plus 2? Alkene is just going to be times 2. Pretty much everything else is the same. So let's build some alkenes together and see what's going on. This time for these molecules, there we go. I am looking at this second version of carbon where we have a double bond. Alkenes have the ene ending because they have a double bond in them, and that makes them unsaturated. Basically, I could squeeze some extra hydrogens in there if I broke that double bond, but because it's there, I'm not as full of hydrogens as I could be, okay? So methene, remember meth means one. This doesn't exist. In order to have a double bond, I would have to have at least 2 carbon atoms. And because meth means there's only one, this is not a thing. It's impossible to make. So let's make something that is possible. Let's talk about ethene. Because I see eth, I know that I need to build it with 2 carbons. So let's do that. Here's my 2 carbons. Let's put them in a neater line. And because I see that ene ending, that means that I'm going to connect them with a double bond. Then what I'm going to do is just fill up the rest so that carbon still has 4 bonds. So this carbon currently has 2. So there's the third bond, and there's bond number 4. Let's do the same for the other carbon. It has 2 bonds, so I'm going to do 3, and I'll make 4. Now, it's okay that there's nothing on the bottom of these carbons because they still have 4 bonds coming out of each one of them. That's what's important. Then I'll just add a whole bunch of hydrogens all the way around on the other ends of those bonds, okay? Now, notice that this is not as many hydrogens as it was when it was ethane, but that's okay, right? This is a different chemical. So this is ethene. Eth tells me that it has 2 carbons, and the ene part tells me that I should see a double bond in it. Let's try that for propene. Remember, prop, the prefix is 3. So let's build this with 3 carbons now. And the ene ending tells me that somewhere, and it doesn't matter where, I could put it between these carbons or I could put it between the other ones, that's fine. I have to have a double bond somewhere though. Then I'm just going to fill everything else in so that all of the carbons get 4 bonds. So there's 1, 2, 3, 4 for that first carbon. The second carbon, if I connect all of these, has 1, 2, 3. Oh, that needs one more, 4. This carbon on the end only has 1 bond, so I need 2, 3, 4. Now, on all of the other ends of these bonds, I'm just going to fill them in with hydrogens. And there we go. Now again, it doesn't matter if the double bond is between the first 2 carbons or the second 2 carbons, as long as it's somewhere in there. So this thing is propene because it has 3 carbons for the prop, and ene tells me there's a double bond in there. So if I just wanted to write the formula without drawing the structure, remember, writing the formula, the prefix will always tell you the carbon number. The difference is, depending on what bond type you have to calculate the hydrogens differently. Alkenes use a different formula than alkanes. Alkanes, it's times 2 plus 2. Alkenes, we're just going to times 2. So for ethene, eth means 2 carbons. Get rid of that, sorry. And for the ene, I'm just going to double the number of carbons. So it's C2H4, and that's it. Let's try that for propene. Prop means C3, and ene means I'm just going to double the number of carbons. So it's C3H6. Now I can go back to my original structures and compare. Did ethene have C2H4? Yes, it did. We built that right. Was propene C3H6? 3 carbons, 6 hydrogens. It's perfect. Okay. Now, another possibility is that we might give you the formula and ask you to write the name. This is a little bit trickier because you have to look at the pattern of the hydrogens, okay? So, when we're writing names, the prefix will always tell you the carbon number. That's the easy part, right? So C2 means F. But now I have to decide, is it ethane or ethene? Which one is it? And I can tell that from the hydrogens. From 2 to 4, did I times 2 plus 2, or did I just times 2? Well, I just doubled it, right? Whenever you're just doubling, that means it is an alkene, so we're going to say this is ethene. Just to compare, if it was ethane, it would be C2H6 because I would have times 2 plus 2. In this one, they just times 2. So let's look at another example. So C3H6. C3 means that I need to use the prefix prop. But did we times 2 plus 2? Is it an alkane? Or did we just times 2 to get the hydrogen number? Well, we just doubled it. When you just double, the ending is ene. And there's everything you need about alkenes.